And we're back. Number 3. Well, when you watch these videos tonight, Tanya, see, you're going to click on one. It will roll right into it because it's on a playlist. And it'll say, and we're back. And you'll be like, oh, yep, now it makes sense. Okay. I believe that more than 2 students in this class were able to find out that ATM means automated teller machine. So, hey, that's cool, right? Learn something new. Texas A&M? I think we missed the order. Texas is first?
They're dyslexic.
Oh, it's dyslexic. All Aggies are dyslexic? Is that what that was? That's what George just said? Oh, George! George can't do! Roberto, swearing? PH. All right. What is the probability at least one ATM is working when them all open? So that's 1, 2, or all 3 are working. So what you need to do for this one, nope, you just need to add them together. So 0.21 plus 0.4 plus 0.24, which is 0.85. Another way some students could do it, I don't think anyone did in here when I looked, but I could have missed it. Some students think of at least 1. The complement of that is none. So 1 minus 0.15 is 0.85. You can do it that way too. Yeah, nice job, Suzette. Excellent. Part B, expected value. Whenever I see expected value, I start thinking, all right, let's take our probability distribution table and multiply these guys and then add them up. So you have 0 times 0.15, 1 times 0.21, 2 times 0.4, plus 3 times 0.24. Multiply in the table, add them up, and you get, what is it? 1.73 atoms. Now, I hope you know that this is just me recording this, so I didn't show any work. Would I show work? Yes, I would show work. All right, so make sure you show your work. Okay, part C. Oh my goodness, it's been a while, guys. I see a given. Do you remember what that is called? What type of probability has the word given? Thank you for pointing to the formula. That's right. Eduardo said conditional. He is right. So you're going to write the probability given at least 1 works. There's our condition. And it wants to know that all 3 are working. So that's going to be equal to, if you use the formula over there behind the boys, your denominator is going to be the probability that at least 1 works. At least 1 works, which you already calculated in part A. What up? And then in the numerator is all 3 work, which is 0.24. Why didn't I multiply? The table there says probably all 3 work is 0.24. Yeah, here's what I've always thought about these questions, right? Because I've been doing this for a decade, so this is familiar to me. So when I explain it, students are like, wait, that makes so much sense. Yes, I've been doing this for a long time, guys. So it will start to click in your brain the more you do this. Don't worry. Oh, I see. Okay, so we're good. Okay. So you're saying I should have written all 3 and at least 1, right? So you're saying I should have multiplied all 3.24 and at least 1.85. No, because the way I view it is, if you tell me at least 1 works, then you tell me what's the likelihood that all 3 work. At least 1 is not the same as all 3. So if it had been, like in other problems we did do this, where we've never multiplied them though. I've never done that. Like I've never done that here. But we have had to write down and find in the problem the and. But this one, the way I view it was, it already gave me all 3. So that's the numerator. The denominator is at least 1. I know that's not a great explanation, so I'm sorry. We'll do more before the real test. Yeah.
The odd number is 28. Right?
Yeah, I'm sorry. It's hard to tell. That's an 8. That made it worse. There you go. All right, so whatever that is. Excellent. Part D. Did anyone answer part D? No. Here's the way I think about part D. Okay? Here's the way I think about part D. What are they telling me is happening in part D? They're telling me at least 1 is working. So when I walk into the mall, what do I know can't be true? That none of them are working, that 0 are operating. So the way I view this is, if I just look at this table now as just these 3, if that's my new probability distribution table, and I take out this 0 one, what needs to happen with these 3 numbers, these probabilities? They need to add to be 1. Well, right now, do they add to be 1? They add to be 0.85. So what's going to happen to the 3 of these? They're going to increase. If you tell me that at least 1 is working, the likelihood of 1, 2, or all 3 are working is going to go up, because you're already telling me it's not 0. So that's the way I view that problem in part D, that if you tell me 0 are not working, then the rest of them have to increase slightly, so I'll have a greater chance of my expected value will be greater than part B.
How do you know how much you increase it by?
That's a great question. I don't know.
So what would you write today?
Yeah, like what do you do?
I would write, let's do this. I'm going to stop so we can move the desk back, and I'll say let's move the desk back. All right. Thanks for listening.